Perhaps people wouldn't think that data analytics company focusing on vaccines and epidemiology would be looking at the size of poultry farms, but that's another data set that we can bring in to help understand the risk.
Big data. Yep. It's become a bit of a buzzword over the last few years, hasn't it? And it can mean a lot of different things depending on who you ask. In essence, though, it's taking a lot of information and using it to find insights that you didn't know were there before. And where there's insights, there's value. Sounds pretty simple, right? Well, not exactly. Because collecting a whole load of information is one thing. Finding use for it, or at least using it well, that's a different thing altogether. And with humanity generating 2.5 quintillion bytes of data per day, I promise that's a real number, and growing, knowing where to look for the juicy bits takes skill. So, that's what we're going to be looking at today. We're going to be lifting the lid on big data, chucking in some finely chopped information, seasoning it with some expert opinion, and hoping a delightful, insightful stew comes out the other end. You're listening to Technology Untangled, a show which looks at the rapid evolution of technology and unravels the way it's changing our world. I'm your host, Michael Bird. Big data is big business. Between 2018 and 2022, the global big data and business analytics market grew from $169 billion to a predicted $274 billion. What qualifies as big data in the simplest terms has grown too. In 1999, a 1 gigabyte dataset would have been considered big data. Nowadays, datasets can run into petabytes or even exabytes, spread across multiple sources and formats. But it's not just about how big your database is, it's what you do with it that counts.
Hello everyone, I'm Vedran Podobnik, Data Practice Lead for UK, Ireland, Middle East and South Africa in HPE. I'm also University Professor of Data Science at University of Zagreb.
What is big data? What do we mean by big data? And why is it so important?
Around 15 years ago, the most important characteristic to say that the data is big data was volume of the data. So basically, if you have mass amounts of the data, then this type of data was called big data. This changed a little bit through time, and there were different characteristics, first known as 3V, then 5V, which take into account the other aspects of how data can be described. So volume is kind of the foundational one. But then with the time, as you know, especially in academia, you always need to write a new paper, meaning you need to basically design the new theory. So then when somebody saw 3V, let me think about additional V's which can be used. So one of those V is velocity, which is connected with how fast the new data is generated. More and more data is basically through streams in the real time coming to data platforms. So the higher velocity of data, the bigger potential of data to be kind of classified as big data.
The speed that we gather information has become a critical component in business over the last 15 to 20 years. Using web cookies and laterally smart devices and the Internet of Things, we can generate absolutely vast amounts of data in near real time and store and retrieve it around the world en masse, close to the point where it's needed. Most of us as individuals take data at our fingertips for granted, but it is easy to forget that many organisations, even those with data at their core, are still generating and collecting data over periods of weeks, months, and even years, a glacial pace in the digital age. Some of them, especially those in the public sector, such as government departments, are still relying primarily on paper filing. So when someone comes along and turns those decades or even centuries-old filing systems on their head, the results can be dramatic. Heather Savoury was the Deputy National Statistician for Britain's Office of National Statistics. She's also worked on big data for the United Nations and currently sits as the non-executive director for the UK Parliament Information Authority. In short, she knows quite a bit about big data, and she spent much of her career transforming big public bodies to take advantage of it.
I became director for data capability at the ONS in 2015, and I was charged with doing a full digital and data transformation. And it was a tough gig. It was a newly created Director General position because the board had realised that the way our national statistics were being produced needed a transformation. A lot of things were still being done on paper. They had attempted a transformation probably about 5 years before I joined, which had been a complete unmitigated disaster. And so I went in and we, with a very good team who worked for me, worked directly to me, we actually transformed how the ONS works. So that included the first digital census that you'll have taken part in. That also included building the ONS's data science campus, which is one of the things in my career that I am the most proud of.
How long's the ONS been around for? Do they have rooms full of old records?
Oh, hundreds of years. There are paper records, which I discovered were in a shed somewhere, and the roof was leaking and we had to get that fixed. There was all sorts of interesting times at the ONS. But one of the main things really was trying to get statisticians to think differently about how they collected and used data, because obviously most statistics is based or was based on actually doing a survey on paper. And surveys are always going to be needed, that you're not going to get away from needing surveys to produce national statistics. But there's all these other very rich data sources which are easily available across government and from business, which you can start to sort of frame the way you're thinking about your problem solving in a completely different way.
With hindsight, it's incredible to think that Britain's Statistics Authority was pretty much paper-based until 2015. But that is the power of digital transformation. It really is, well, transformative. By turning paper data into digital data, the ONS was able to compare and contrast it to other data sets and data sources and come up with a whole new way of looking at information. In short, they were able to look for insight among the data. And that pretty much gets to the core of what big data means today. But to do that, you need to take advantage of different data sets. So let's not get ahead of ourselves. Here's Vedran again.
The third V is variety. So this is about different types of data that exists. Initially, majority of data was structured data, stored in databases, big databases. But with the time, we more and more talk about unstructured data as well. We talk about specifically from the big data perspective about the multimedia data, which is huge by definition. So, for example, CCTV recordings.
Looking at unstructured, or rather differently structured information, and overlaying it with data that's been shared or made public opens up a whole new world of opportunities. It's something Heather Savory is keen to explore, and it can have dramatic real-world consequences when different sets of data can be combined to address real human needs.
Think of the apps that you have on your phone, bus checkers. When you're standing at the bus stop in London, you can look on your phone and where the number 93 bus is. Well, you know that because TfL released that data as open data and allow people to build apps on top of it.
Yeah, which is really powerful, isn't it, I guess?
Very powerful, yes.
You can let other people do some of the innovation.
And the owners of the data which is collected for a particular purpose are, I think, generally really surprised by the other things that people do with that open data. Because it's things that and it's not competitive to their core market or their core purpose, because it will be something completely tangential. If you're in the unfortunate situation of buying a property at the moment with the way interest rates are going, and you want to see whether or not your flat or house or bungalow or caravan, if that's all you can afford, is subject to flooding, you can actually look at the flood database, which is based on this open data from the Environment Agency.
Yeah, so that does raise an interesting question though. If data is open source, or has at least been made public, you are kind of taking it on trust that the information you're using is up to date and accurate. You have to take it on trust because it's not your data. You've just been given access to play with it. Here's Vedran again.
Then we had the 4V and 5V theories. 4V was veracity. This is explaining how trustworthy data is. So when we talk about data, it's not only about having huge amounts of data, but can we trust this data? And this is specifically when we talk about data from the perspective of data being used by senior manager in the company. The question is, there's a dashboard showing some kind of analysis on the data, but the question is this data right? Can I trust this data?
Bad data, or I suppose counterintuitively the fear that your data could be revealed as bad data, is something Heather Savory has come across often in her career. After all, she used to be the independent chair of the Open Data Group, which advised government departments on releasing their data and research for wider use and the greater public good. And let's be honest, wherever we are in the world, our governments aren't always known for their openness, or for, not occasionally muddling the figures.
So each department has its own data, and despite data sharing legislation, it has proven extremely difficult to actually get departments to share data. People tend to want to sometimes keep their data to themselves because there is no such thing as a perfect data set. And people become very concerned that actually the management information that they have is flawed, and they don't want people to know that they're making decisions on a day-to-day basis based on flawed information. Although actually everybody is anybody's data perfect? And we sort of need to think about being more transparent about the real state of our data so that it can be improved. As soon as you open up a data set and let other people look at it, they will identify issues with it that you haven't noticed yourself. And that means you know where the problems are, and that actually means you can fix them. But taking that step is a very big step for most people.
Let's be honest though, with the best will in the world, no organisation's data is perfect. Not that we'd admit it. So I guess we're probably no better than the politicians, aren't we? And that means there's a question to be asked within organisations about the value or risk, depending on your perspective, of having your data scrutinised versus the potential enormous opportunity of releasing data and the insight that it could bring. Here's Vedran.
The fifth V is value. And for me, with the time, that V is more and more important. Why? Because when we think from the perspective of huge amounts of data which has been generated today, in 2022 we are talking about 50 to 100 zettabytes of data. So it's huge amount of data which is generated yearly. So if you think just from the perspective you need to store this data somewhere, this is a huge cost of storing the data. So the question is, why should someone store data? Individual organization, if you store data, you need to pay some money for it. So if you recognize the value for your data. So I would say specifically for the organizations, more and more they think from the perspective, should I store the data or should I delete the data? If I'm storing the data, am I storing the data in hot tier, meaning that I can access it all the time, but this is usually kind of more expensive way to store data, or I'm going to archive it somewhere, it's not deleted, but still you need to pay some money for it. There is also the term dirty data, which is used quite often today. This describes the data which is stored somewhere, but with really low potential of being used in any way on the benefit of the company. This is why it's dirty data. But it's not easy to identify and differentiate between dirty data and really the data that can be valuable. So here the importance of metadata, data governance comes into place. And the reality is that still we don't see the right technological solutions which would enable to do a proper large-scale metadata management and governance. There are a lot of technologies which can be used for different niche or siloed data types, but we are currently missing the overarching unified approach to data governance.
in organisations, is there some sort of tug of war between wanting to store as little data as possible, because that data has to go somewhere, and wanting to store everything or as much as they possibly can, because they might use that at some point in the future?
Tension, I think, is the right word here. So you can always feel the tension between teams who are responsible of platforms and users of the data, right? Because usually users of the data, they are not aware of really cost of storing the data, because the costs corresponds with the platform teams. So of course, they want to minimize the cost and also minimize the complexity of the systems. It's much easier if you can have the data platform which is sitting on 100 nodes compared to data platform which is sitting on 1,000 nodes from the perspective of maintenance and the management. While this also means that you can store 10 times less data. So the question is, how to find the right balance between those two. And then again, here we come to the question of data management and data governance, understanding really what data is important, what data you need to have, and what data is not going to be useful. And so this is the challenge, I would say, today when you talk about big data, is companies need to think from the perspective, how I'm going to analyze this data to get insights out of the data. So the question is how companies transform data into value. And for me, if we talk today about big data, this is the most important V today, value of the data.
So value is a question of potential benefits to our organisations by sharing information, and a question of the literal cost of storing the data somewhere. But we humans are pretty ingenious, and there are organisations out there which have spotted an opportunity to bridge that gap. To collate the vast data of several organisations, much of which is of little value to anyone else, and overlay it with other data and human expertise to do the hard work of generating insight third parties can benefit from.
My name is Louise Blair. My job title is a lead analyst at Affinity, and I'm head of vaccines and epidemiology. Affinity is a life science predictive analytics company. We gather all data on the clinical pipeline in infectious diseases, but also other diseases such as within cardiology as well. So we understand or identify what's going on in the pipeline, all the way from discovery and preclinical, through the clinical stages to approvals, but then beyond that as well. So the procurement, manufacture and production of all these candidates. So gathering data from all the different sources that are out there to try and make sense of that in one picture. For example, understanding what is coming through the pipeline for COVID-19 and what impact that can have on the current cases, hospitalizations and deaths that are happening, but also happening or will happen in the future as well.
Affinity collects and collates vast amounts of data from myriad sources on new medical and pharmaceutical research. It then overlays it with human expertise and other raw data from hospitals and public health bodies to try and garner insight that can then help drug manufacturers, governments, and others to strategically plan for the future. They deal with a massive amount of information in a huge number of formats, often siloed or stored in a way where it can't really be easily digested or connected to the outside world. So combining that silo data has huge potential, as Vedran explains.
One of the biggest challenges that organizations face today is silo data, meaning that for different types of data, they're using different technologies, and those silos are not connected. And the great thing about the data is that 1 + 1 sometimes does not equal 2, but can equal 3 or 4, because you can get additional insights, additional value can be extracted from the data if you combine silos. Connected data is very important.
And connected data has allowed Affinity to do what it does so well. What does Affinity do with absolutely vast amounts of data?
We're trying to gather it from all sources, really. So I think traditionally in science, there have been sort of very set places that you would find information, whereas especially within COVID, but more also sort of for other diseases over the past couple of years, that's really expanded. There's a lot of information out there, but it's becoming more difficult to make sense of it all in one place, and that's really our key aim.
Can you quantify how much data, maybe it's a trade secret, but like sort of how much data could one gather around a single drug or a single, I don't know, something like COVID-19, for example?
Yeah, it's quite, I guess, hard to quantify exactly in terms of the different diseases, different candidates. But pretty much any bit of information that is out there we're gathering. So whether that's just the name and the alternative names to a drug, to all the press releases, papers, results, efficacy results, either from clinical trials, but also all the real world studies that are happening as well. We're gathering information on animal-human interaction. So an example of this, trying to understand potential avian flu outbreaks and what could lead to an avian flu pandemic, looking at countries, looking at their population size, looking at the frequency of interactions that they may have with large groups of animals. So if you think of large indoor poultry farms, if there's a lot of interaction, or large farms with a lot of human interaction, there's an increased risk of transmission. We, of course, all know about live and wet markets and potential risk that they can have following the COVID-19 pandemic. So gathering all that data can help us understand hotspots of risk going forward. Now, perhaps people wouldn't think that, a data analytics company focusing on vaccines and epidemiology would be looking at the size of poultry farms, but that's another data set that we can bring in to help understand the risk. And if we didn't have the expertise to understand what are the potential hotspots and contributors to potential transmission from animals to humans, we wouldn't look for that sort of data set.
So what Airfinity are doing in this respect is finding new perspectives from what has been dubbed data fumes. I asked Vedran to explain what that actually means.
Good question. As with everything in life, and this is really valid for politicians, they always say, when you cite them, if it's something that they don't want to be cited on, it's taken into wrong context. But this is the same as with data. So context is very important, because same number in different contexts can mean completely different things, right? So from that perspective, when we talk about data fumes, which you mentioned, here we are talking about the context of putting data in the environment. Today, where we have, mobile phones, smartwatches, which are on all the time, and if we enable them to basically record how we move, then somewhere in the cloud, they can basically store the traces of, how we moved the different geolocations. Data fumes is a concept how you extract the value out of this data. So it enables companies to access digital footprints of the customers, and then enables them to analyze the data in an innovative way to create different insights about the users.
Why is it called data fumes?
It's called data fumes because, and I'll take my academic hat now again. In academia, basically, the measure of success is how many new scientific papers in impactful journals you can write. And then in order to be able to publish in those impactful journals, you need to be a little bit creative and you need to be a little bit provocative, right? The data fumes term was coined in one scientific paper by one scientist. So
fair enough. All right.
So the phrase is a bit of a buzzword, but the value it can offer is very real. In fact, understanding data in different contexts was core to Heather Savory's digital transformation of the Office of National Statistics in the UK.
A traditional statistician thinks about what they want to know and then commissions a survey to ask certain questions to gather the data that they want. Now, what we wanted to do and what we did do was to bring in all these data sources and to turn that on its head so that rather than thinking, what data do I need to answer this question, you think, what data have I got and what can it tell me? And when you bring this data together, you can actually look at it from multiple different angles and merge different data sets together to answer a whole plethora of questions that you could never answer using surveys. So A good example is during Brexit, we produced some very early trade estimates using shipping data and using actually open data on shipping and aircraft. There are actually some early economic indicators based on big data sets and things like pricing data from supermarkets and other stores, so that there are the actual estimates of the economy. Not only are, I believe, better quality, but more importantly, actually, they are closer to real time. Because if you get from one of the major supermarkets, a list of who's buying what and what it costs, that pricing data is just, it's the exhaust from them selling the food to us all. So you can do that. I mean, one of the really most powerful sources of data is geospatial data. So you can use geospatial data to look at deforestation in the Amazon. And you can actually do that. If you look at deforestation across the globe, you can make a really good estimate as to what's happening regarding climate change. You can look at water sources and water supplies.
And it's not just in predicting trade patterns or global warming that big data and data fumes can play a huge part. There are times when it can literally be life or death for organisations as well, especially when it comes to cybersecurity. Using insights gleaned from thousands or even millions of interactions and data points can help organisations identify potential attacks and help security teams deal with them. You might remember in our last episode, HSBC's Chief Cybersecurity Architect, George Webster, spoke to us about protecting the bank from ransomware attacks. Well, it turns out data insight can play a huge part in that.
So your PhD was on developing methodologies and techniques for large-scale security analytics. Can you briefly explain what that means to a layperson like me? And just give a bit of a sense of how the field has evolved since you did your PhD and how that's going to continue to evolve, how you think it's going to continue to evolve.
I mean, for my PhD, I just wanted to goof off in Germany for a bit. That was really the PhD. No, so the PhD kind of came about, and it really became from my frustration with the current affairs. And you still see it today. Cybersecurity is often very vendor-led. And I would argue, the vendors have let down, the security community. It takes a really long time to change the tools. The goal there was to kind of look at it of how can you start to change it? How do you start leveraging data and insights and start to unlock the human? So don't rely on that tool, but unlock that human to be able to perform an investigation and be empowered to make effective decision making. So how is the field really evolving is you're actually seeing the field massively go towards that, right? We talk a lot about various cybersecurity toolings, but if you see it, big data landscape, for instance, Databricks has a cybersecurity capability. A lot of the recent upstarts in the venture capital world, again, you're seeing analytics more and more. You're seeing also a lot of these major corporations starting to stand up data science teams to start to help and augment.
And that's a key with big data. It's about giving us humans more insight. Nowhere is the idea that big data is there to enable humans rather than replace them clearer than with groups like Airfinity, who are taking enormous and disparate data sets, for example, vaccine trials and livestock supplies, and then tying them together to generate insights. It's not the kind of task an AI is currently suited to.
Yeah, I think what was quite striking when I first started at Affinity is that there weren't many people doing this type of work. So trying to understand the picture as a whole, but also with the depth of knowledge within each disease. And I think what sets us apart differently as well is that we have individuals that are specialists in each area. Because I think sometimes, yes, we have all this data, and I think there's been quite a few of armchair epidemiologists over the course of the pandemic.
I was one of them.
Sometimes we can get data that is out of context, and we don't really understand the impact because we don't have that understanding of how perhaps the vaccine manufacture works and how that can then have an impact on epidemiology. I would say, over the past couple of years, we're trying to work very differently to make that picture a lot clearer in terms of future impact in the vaccine space. And we've been working with not only governments, but biotechs and pharma to understand that race of vaccines. So what's coming on the market, how quickly or how likely they are to progress to the next stage and to approval, to really shape their vaccine portfolios.
So are there things that we can do today that we maybe couldn't have done, say, like a decade ago?
Yeah, definitely. I think just in terms of the volume of data that is out there and being able to collect this data all in one place and then have specialists really analyse it. So we may have previously been able to get an overview of what a single company is doing in the UK, but we're now scanning that across the world. But I think it's the interplay, because we are able to process data in a very different way now than 10 years ago. We can look at the broader picture rather than just focusing on the pipeline or just focusing on the epidemiology. We're able to put that all in one place and gather that in a way that we haven't been able to before.
If there was another COVID-19 style outbreak in the next, 5 years or so, let's really hope not, what would you and Airfinity do differently based on what was learned during the pandemic and all of the technological advances that have happened in the last few years?
So I think, first of all, it's just the horizon scanning of what's happening worldwide. Yes, we hope that a pandemic like COVID-19 won't happen within that time frame, but there are outbreaks of different diseases happening all the time. For example, the Ebola outbreak in Uganda at the moment. And it's being able to monitor each of these outbreaks, understand what the countermeasures are. So are there vaccines available? What type of lockdowns or restrictions of movement actually work for each type of disease, and how that all interplays. We can get that information to people on the ground or governments or pharmaceutical bodies all at the same time, sort of very rapidly in comparison to what we were able to do maybe 2-3 years ago. So we're able to advise a lot quicker. We're able to act on any outbreaks a lot quicker, and therefore could help stop an outbreak that could lead to the COVID-19 pandemic or a similar situation. But we need that horizon scanning to continue. We need that data to continue in order to help with that process.
HSBC's George Webster agrees that humans are still at the core of gathering insight. Even in the groundbreaking world of cybersecurity, where machine learning is taking off and you'd expect most cases to be handled by software and algorithms, the role of AI within big data isn't to advise based on wide, disparate data sets. Instead, it's there to assist the human by filtering out noise whilst the human provides the insight, or helping them execute their decisions and strategies.
What is AI? In many ways, there's nothing really intelligent about these AI systems. When you talk to machine learning, for instance, right, it's just rapid pattern matching. There's nothing AI about it. It's just how do you do pattern matching. You look at SMT, it's, you're basically just finding the shortest path or solving the equation. That doesn't mean those patterns in those AI methods, right, don't have massive bang and huge significant benefits. But it's kind of hard in the cyberspace. Like, how do you find a pattern when the pattern's constantly changing? I don't know where the threat's going to come. No one ever will. We can't predict the future. So it becomes very difficult and very challenging. But what you do see is a lot of these AI methods and techniques start to come into play for, how do you start accelerating and processing? So, MapReduce, for instance, is an algorithm that allows you to distribute your execution. Well, that's often in the AI world, it's heavily used. Now you're seeing the same thing. We have huge volumes of data. So to be able to query it, we're not just using like a reverse index, if you will, or a search engine. Now you're starting to see us use the techniques like MapReduce to do the work. Those are really, really complicated and long answer. But the sum is you're you are seeing AI being leveraged and you are seeing it being used, but not in the traditional sense. You're seeing a lot more of them starting to use those techniques to start to incorporate more data-driven methods.
Fascinating stuff. But here's the thing, and it's one of the big arguments of big data. These organizations are using our data. Governments across the world take information on us and our spending habits and our lifestyles, and they compare it with information taken from other government departments or public information on everything from flooding to bus times, and then they create insight. Our banks use our interactions to learn whether we are suspicious or dangerous actors. Flight patterns can be used to predict disease transmission. Now, our names might not be attached to that information, but that information is ours. We made it. So, does that raise any concerns about how it might be used? Well, Heather doesn't seem to think so. Certainly not at a state level.
The way I like to think about it is like this. So we are part of society, and society is run by government. And in order for the government to work out what it needs to do, it needs to know that we exist. You know, that's why we do the census. It needs to know where we live in aggregate. So it knows where to build houses, hospitals and schools. And you need to be part of this big data as an individual in order to get the things that we all then complain about. You know, if you're not even on record as part of a demographic, then there's absolutely no way that anybody can even try and get it right in government. So that's one thing. And the second thing is, I think that there's so much more information available to people now. You know, the things that we've talked about, you know, the apps that you can get, the things you can look up, the things you can do. The real challenge for us in our society is really now around digital exclusion, because there is so much that's going online. And one of the things I have to say that I am the most proud of, which we managed to do at ONS, was actually get the systems in place which have enabled the day-to-day COVID infection reporting, which everybody saw on the news and sort of took for granted. So if you think back 10 years and there was a pandemic of that nature, there would be no way that you could actually find out what was happening across the country. There would be no way that you would know what concentration of sick people there was in your local area. So, you know, we're all actually empowered by the good use of big data.
Yeah, I think I found that actually that was probably the first time that I'd really seen government data so overtly, you know, accessible, and exactly what you said. You could go through the layers to your local area and see how many infections were in basically your tiny little ward or whatever it would have been. And actually, I think that was really fascinating that you could get from that level, and then you switched on the TV and they were showing graphs and basically explaining data to the general public. And I thought that was probably the first time that sort of happened, that a government representative has gone on national television and shown a graph and said, this is our decision and this is why we've made that decision. And I thought that was quite interesting, because government can sometimes feel a little bit opaque with the way that they make decisions. So I thought that was quite fascinating.
Yes, and really, I think that as a member of with my member of the public hat on, I would say that government should be doing more of that.
Yeah, I agree. Vedran has his own thoughts on the privacy argument.
This is not an easy question. It's not an easy question because if you constrain yourself too much, either through regulation or self-regulation or not wanting to disclose too much information, this means that you also are constraining yourself from the perspective what value you can get out of the data. So there should be a balance, because if the balance is crossed in a way that you are disclosing too much, this means that information can be misused, right? But if you are constraining too much, then you are also in a way blocking the innovation, but also you are not helping the data scientists, data analysts to build the new systems which are going to, in the end, make our lives better, make our society better. Because if you want to have technology with capability to predict, whether there is a big potential that a heart attack is going to happen tomorrow, you need to share a lot of your personal data about your heart rate, but also the other kind of sensor data which is collected from your body, also contextual information about potentially where you went. So it's, again, the balance between technology, what individual as a user wants to basically do with technology, whether they are comfortable with sharing the data with technology organizations. I'm not fan of being too strict with the regulation, but again, it's clear that if we take a look what is happening with social networks and social network companies in the last few years, and what is more and more happening today with AI, which is being more and more regulated as it's becoming the mainstream technology, it's important that, firstly, people who are working with technology, they are aware of everything that can go wrong. Sometimes people are just not aware how data can be misused, or if they are building some kind of AI system, how those can be misused. And then the regulation comes afterwards. I would say we need to work more on enabling people to be aware of everything that can be achieved, to be aware of all misusages of technology and the data that can be done before we are kind of really preventing and regulating things in a way that we are kind of blocking innovation.
So, big data. It is big business. And once we get over the challenges of what to store, how to analyse it efficiently, and regulation where it's needed, it'll become even more of a game changer in improving our lives, with everything from better traffic flow to better health outcomes and better business efficiency. In fact, that's already happening. It's just going to happen a lot more. So, I guess the final question is, where will we be in 10 years' time? What will the ever-evolving science of big data mean then? Here's Heather to see us out.
Oh, crystal ball.
This is crystal ball time.
Crystal ball question.
And we'll play this back to you in 10 years.
Okay. Well, I think people will be much more used to the concept of the better use of data, the use of big data. I think that the real challenge that the world faces is around regulation. There is an absolutely massive challenge, which I encountered at the UN. I mean, I tried to get countries to share data with a common purpose for the common good to measure the Sustainable Development Goals better. And to a certain extent, they are sharing it better. But the real problem is that you need global solutions. No country is isolated anymore. So it will be very interesting to see in 10 years' time how the world has changed with respect to where does the data and information power base lie. Is it still going to be Google? Is it still going to be in the US? Is it going to be elsewhere? We in the West aren't entirely happy with some of the things that the Chinese do in terms of their use of data, particularly surveillance of their own population. But taking a step back, if you think about being not in small towns, not in the countryside, as soon as you get on a train, even in rural areas, you're on camera here. We are not as far away from that as people might like to think. And I would be interested to see whether or not people become more or less worried about that, because going back to what I said before, to be part of a society, you have a digital footprint, and increasingly we have as much or more digital footprint than we do physical.
So Big Brother may not be watching you, but big data might. It's all right though. He's probably friendly. You've been listening to Technology Untangled. I'm your host, Michael Bird, and a huge thanks to our guests, Vedran Podobnik, Heather Savory, Louise Blair, and George Webster. You can find more information on today's episode in the show notes. And this is the 9th and final episode in the 3rd series of Technology Untangled. But fear not, we'll be back with an all-new Season 4 later in the spring. And we've also got a whole new weekly magazine podcast coming. It's called Technology Now, and there's a lot more on that in the description. In the meantime, be sure to hit subscribe in your podcast app of choice so you don't miss out, and to catch up on the last 3 series. Today's episode was written and produced by Sam Datter and me, Michael Bird, with sound design and editing by Alex Bennett, and production support from Harry Morton, Alicia Kempson, Alison Paisley, Alex Podmore, and Ed Eversden. Technology Untangled is a Lower Street production for Hewlett Packard Enterprise.